our topology, it's very easy for you. We use a DHCP to assign IP address, and we also use the VLAN to limit the broadcast domain, right? And the next one, if our topology, they also have some other problems we have to solve. For example, about this part, if there are only one distribute switch, if this switch is broken, all the terminal cannot reach the internet, right? So about this one, we call is a single failure. So how to solve the problem of single failure? Because if this device is broken, we cannot visit each other. We cannot communicate with each other, and also we cannot to visit the internet. About the network, it's too we don't have the high ability of the network. So how to make our network stronger? Do you have any suggestion? How to make our network stronger? Maybe we can add a new device. Also, maybe one link is broken. They cannot communicate with each other. And we can add a new device. And we can provide multiple link here. In this topology, if one device is broken, or maybe one link is broken, we still can wait with each other, use the other device and the other link, right? So that's why we say we have the high availability of our network. But if we use this topology, there's also another problem. For example, if now the computer send out the broadcast packet to access switch, right? The access switch will do the flood, send out to all the switch. And then the call switch will forward the broadcast packets to the flood again, also to this switch. And then the switch also will send the packet to the access switch. So in this topology, there is a loop. Pay attention about the loop. If the loop is not solved, we will make this one we call is a stone stream. All the bandwidth will be wasted until the network cannot work. So why we add the device at the beginning? We hope that we can provide a high ability. But if we add the device and add the link, there is a loop. So how to solve the problem? If we want the device, we want the redundancy function and also avoid the loop. There are any suggestions? There are any solution? Someone maybe say, if I delete the link, there is a no loop. And if one link is broken, I will add the link. And we also have the backup one. So maybe someone say, I will use a cable and stick the interface, stick the network all the time. One, I have to add the link. One, I have to delete the link. It's too tired for you, right? We want some technology to solve this problem. Also can provide the redundancy function and also can avoid the loop. So this technology we call is STP. So about the STP, how to work, how to delete the loop, how to provide the redundancy. If you want to know the detail, 10 minutes later, let's have a break at first. 10 minutes later, let's continue to next part. Okay. Let's have a break 10 minutes. And I have a radio for you. It's a little tired because we focus on the computer already 1 minute, 1 hour and a half, right?
Blink for a minute.
Let's do an exercise.
This exercise helps to regulate blood circulation inside your eyes. Take your time and let's begin.
Please come back 10 minutes later.
Blinking is an excellent way to relax your eyes. It has 3 functions. It helps grease your eyes, clean them, and give them a break.
Yes. It's better for you to do the sports. I think now you can continue maybe 3 hours, right? Okay. Let's continue. Now it's very good for you to understand the next part. Okay, let's say why we need STP, right? Because we want to avoid the single point failure, and also we don't like the loop environment in our network, so we can use the STP. So about the STP, this is a layer 2 loop solution. Of course, about the layer 3, when you deploy the static route or maybe dynamic route, if you give some wrong configuration, there also will be a loop. But about the layer 2 loop is very difficult because until your network is broken, otherwise the layer 2 loop will exist all the time. But about the layer 3 loop is better. After more than 256, one by one, finally the packets will be discarded. So how to avoid the layer 2 loop? We can deploy the STP, spanning tree. And what's the principle of the spanning tree? Pay attention. The spanning tree, the principle is very complex because we will exchange the packets and to select who is root, what's the rule of the interface. Finally, we have to blocking some interface, and then we can avoid the loop. So all the switches have to know why you were to become the root, why my interface finally will be broken. All the switch will exchange some packets. This packet we call is BPDO. B is bridge. Before we use the switch, we use a bridge in our network. So here the bridge means a switch. We will exchange the BPDO message into different switch to select who is a root bridge, and then to select the interface of the root port RP, and select the DP designated port. And this interface finally can forward the traffic, and the rest of the interface will be blocked. So logically, there only one path between different terminals. If one link is broken, we will enable one blocking interface automatically, so we can continue to use a backup link. So this is the main principle. And of course, how to select the root, how to select the RP, how to select the DP, a little complex, we can skip it. If you want to know the details step by step, maybe you can focus on the YouTube video in the future. So the main principle of the STP in the network, we will select one root bridge in the network. That means one switch will become the root bridge. About the one root port of the non-root bridge, only one switch will become the root bridge. All the other switch will become the non-root bridge. And in the non-root bridge, we have to select one RP root port. And how to select RP? To choose the the smallest cost to indicate with the RP. Because about the cost value is depend on the bandwidth. Higher bandwidth, lower cost value. So we will select the smallest cost value to become the RP. Finally, can forward the traffic. And one DP in the segment, you can think one link, we need one DP. And the non-DP will be blocked. So this is a principle. And I will give you the example to select what's the detail. For example, about the switch, if we enable the STP, every switch we will have the switch priority. And we have two parts. One is the priority value, and the second one is a MAC address. And how to select who is a root bridge? We will compare with the priority. Smaller value one is better. If the value priority value is same, we will compare with a MAC address. Smaller MAC address is better. And by default, the priority is 32768. This is a default priority of the switch. If the priority is same, we will select the smallest MAC address to become the root bridge. So the first step, we have to select who is the root bridge, right? So according to the principle, who will become the root bridge? Can you give me the answer? Who will become the root bridge? Switch 3, right? Yes, 3 is a root bridge. So 1 on 2 will become the non-root bridge. So this is the first step. We have to select who is a root bridge. And then the next step, on the non-root bridge, we have to select one root port, one non-root bridge, one root port. So how to select the root port, the RP? We will compare to the cost value. Smallest cost value will become the RP. So like about the switch 1, we have two interfaces to connect with, we can have two interfaces to wait with the root bridge switch 3. One interface and another interface. This interface, the cost value is 100. But this interface, the cost value is 500. So finally, switch 1, this interface will become RP. The same process about the switch 2, this interface will become the RP. Yes, one non-root bridge, one RP. So this is the third sentence. And the next sentence, one segment, one DP. This segment, we need one DP, right? This interface already RP, so this will become DP. The same, this will become DP. So about this segment, how to select which interface should be DP? This interface, the left one or the right one. Also compare with the cost value. Who is the smallest with the root bridge? Who will become the DP? So about this interface, the cost value is 100. This interface, the cost value is 200. So finally, this interface will become DP. And the rest interface will become broken. Okay, so in this topology, if all the link can work, this link will not follow the traffic. So if PC1 sends the packet to PC3, when the switch 1 receives, I will send to switch 3, and then send to switch 2, finally send to the PC3. So there is no loop, right? And if in this time, the link of the switch 1 and 3 is broken, then the interface can work normally. So PC1 send out the packets of switch 1, and switch 1 will directly send to switch 2. Switch 2 will send to PC3. So this is a function of the STP. It's easy for you to understand, right? Then the configuration of STP. About the principle of STP is very difficult, but the configuration is very easy. First, we have to enable the function of STP. The key command is binary mode. We can choose the STP. And the parameter we can change, one is change the priority of the switch. For example, binary, the priority is which one? By default, this is a priority value. And besides this one, remote Y. Besides the priority of the switch, we also can change the cost value of the interface. Okay, change the port value of the interface. And we can change this value and finally to select who is the root bridge and who is the RP, who is the DP. Why? Okay, so this is a configuration. What's maybe you can directly open your voice. What do you want to do? Hello? Hello? Okay. This command a little wrong. The configuration seem to change the priority of the switch. We also have the command to change the cost value of the interface. So finally, we can decide who is a root bridge. Why? Any problem? Yes? Okay, so this is a configuration. And the important one is the port status. We can have different rules, right? The blocking port and RP and DP, pay attention. We also have different status, blocking, listening, learning, and forwarding. And different status, we can have different function. So any problem of you about the Eric? Can you open your voice to directly ask me? Hello? Okay. Pay attention, different status we can do not we can get different function. How to select who is root, who is non-root, or what's the interface type? We will receive the BPDU and send out the BPDU and compare with each other, finally to define the rules. And pay attention, if you finally will be blocked. What's the problem? Okay, finally, if you are a blocker port, you will state in the blocking status. And in this status, we only can receive the BPDU because we will receive the BPDU to detect the calculation between different switch. But you cannot send out the BPDU, you cannot learn MAC address, and you cannot forward the date. Because you cannot forward the date, so we can avoid the loop. And about the RP and DP, finally will be keep the forwarding date. You can receive and send out the BPDU, and you can learn MAC address, and then you also can forward the traffic. But pay attention about listening and learning. This is a major process. For example, maybe you will finally to become a RP. You have to keep the data from blocking to listening to learning and finally to forwarding. And the different data we will do different function. About listening type, we can send the BPDU out. About the learning type, we can learn the MAC address. Of course, why you have to learn the MAC address? In order to forward the data successfully. So this is a port status. And about the STP, here is a practice for you. Which of the following statements about the state of STP interface is incorrect? Which one is correct? Which of the following statement is incorrect? A, B, C, and D. A, right? A is incorrect. A blocked interface can receive the BPDU, but cannot forward out. The option D is correct. We say about the blocked interface can receive the BPDU, right? Why we need to receive the BPDU? Because I have to detect my the other side can work normally or not. If not, I will have to enable my interface. That means I will automatically switch into the listening, and the next step maybe will become learning and then to the forwarding. So the correct answer should be A. Yes. And the next problem is about the STP. There is a port state migration. If the interface to become DP or to become RP, finally we have to forward the traffic, right? But before you forward the traffic, you have to make your data to become forwarding. From blocking to listening, listening to learning, learning to forwarding, we have 2 times forwarding delay time. And by default, the forwarding delay time is 15 seconds. So what's the result of this 16 seconds? For example, here are 3 switch. We have the terminal and we have a server. By default, maybe there is a link is broken. And if the link blocked, we have to enable the blocked interface. And when you enable this one, you have to wait 30 seconds at least. Maybe when I become the forwarding state, then the link will become up. So every time the topology changes, I lost access to the server for at least 30 seconds. So 30 seconds actually is too long for me. Maybe now I open the website. If I need to wait 3 seconds, I also think this is too long for me. So this is a disadvantage of the STP. If the topology change, we have to wait so long time. So how to improve the STP? We can use another one, RSTP, rapid STP. So about RSTP, developed from STP. So RSTP have all the functions of STP, and this one is faster than the STP. So we have so many rapid mechanisms to make when the network change, we can make the convergence faster. And the different one, RSTP, we make the data only 3, discarding, learning, and forwarding. And the rule also is different. RSTP also have RP, have DP, but the different we add the AP, alternate point. This not is access point, okay? This is alternate port. This is a backup for RP. And the backup port is the backup of the DP. So about the detailed mechanism, I will not talk here, but you have to know RSTP is faster than STP. And the configuration is similar of STP. You can select the mode to become ISTP and change the priority. Oh, it's okay. So this is a configuration. But someone say STP is not so good, so I use ISTP. But ISTP also have some problem. And about the STP and ISTP, they are only one tree. What means one tree? One tree means, for example, now about this topology, we have different VLAN, right? VLAN 10 and VLAN 20, and we make all the link between switches to become trunk. And finally, if we use STP or ISTP, we have to block one interface. Maybe it's switch A and B. This interface is blocked. And finally, all the traffic will be forwarded between using the blue line. That means this link is a waste. Until one normal link, for example, between switch A and C is blocked, this link can work. So maybe, especially in the data center, your interface, your link has higher bandwidth, like 10 GB, 100 GB. If one link not work at this time, this is a waste. So if I want to use the load balance, that means all the link can work, can forward the traffic. How to solve this problem? We can use another technology, we call it MSTP, multiple spanning tree. And about the MSTP, we can have the load balance function because we can have multiple instances. And different instances, we can bound in different VLAN. For example, in this topology, if we use the MSTP, finally, if we want to forward the traffic in the VLAN 1 and VLAN 10, we can use the red line. But if the VLAN 11 to VLAN 20, we can use a blue line. So in this scenario, all the links can work with each other. So this is an advantage of MSTP. Compare with STP, RSTP, and MSTP, the basic function to solve the loop failure and achieve redundancy backup. This is a basic function. About the fast convergence, only RSTP and MSTP can have. And another one, if we want to achieve load sharing, only MSTP have. That means MSTP can have any good advantage of STP and RSTP. So this is MSTP. So if you want to use a load balance, let's say the configuration. For example, here we have 4 switches, 1, 2, 3, and 4. And if you want to use the MSTP, we have to add some basic configuration like create the VLAN, use the SVI interface. That means the VLAN interface. And we also have to add the VIP configuration. Usually, we will use the VIP and MSTP together. Of course, VIP is not today's topic. This is the backup, also is a backup solution, but for the gateway, for the IP address. So about this part, maybe we can skip. We only focus on the MSTP. About the MSTP, core switch is switch 1 and switch 2. First, you have to enable the MSTP. Then you have to give the MST configuration, to give the name, to give the version, to add the instance 1 and 2 to bounding the VLAN. Then, for example, about the switch 1, I hope this is a root bridge of the instance 1, working for VLAN 10 and 30. Switch 2 is the root bridge for instance 2, working for 20 and 40. So you can have different priority for different instance. The instance 1 priority is 4096. Instance 2, the priority is 8192. But the priority is different of the switch 2. Instance 1 priority is lower than the switch 1. But about instance 2, the priority is higher than the switch 2. So in this scenario, different instance we have different root bridge. And about this is the main difference. The first part, the name, the version, the instance bounding have been same in the switch. And about the access switch, we also have to add the first part to be same. And the priority, if you use a value like 32, 76, 8, if you use this value, you can directly don't add the command because this is a default priority. So this is a main configuration of MSTP. So now I have a question for you. Do you think MSTP is good enough for you? If in the future you want to get the redundancy backup and also can provide the load balance and avoid loop, do you choose the protocol of MSTP? Do you like MSTP protocol? Oh, you like BGP and ECMP, it's good. But how about layer 2? Because BGP and ECMP is layer 3 function, right? If in your layer 2 you have so many switch, how to avoid the loop and the backup? Yeah. Yes, you can see more expensive switch. Yes. Okay. Yeah. So compare with the switch, the STP, ISTP is better, right? Compare with the ISTP, MSTP is better. But why so many scenarios? Not all the scenarios choose the MSTP because it will make you headache. The configuration is too complex. Because in this example, you only have 4 switch. You only have 2 instances. Maybe in the real network, you have 10 switch, 10 instances, and you have to select which one for which instance. The configuration is too much. And if there's some problem, you do the troubleshooting also will be very complex. That's why not all the scenario will choose MSTP. So any good solution to achieve this requirement also can have the better backup, also can avoid the loop, and also we can use all the link in the network